Brian,
Yes, sir.
yes, there's another venue with technical issues. They are solving their problems. Uh, I think we can start right now. The other venue is going to connect during the session.
Okay,
Well,
very good. So shall we begin at this point?
yes, I'm going to talk about your curriculum and present the conference, and then you can start. Is it okay?
Okay.
Okay.
I see one of my slides behind you, but it is not the slide that I am showing.
Oh, don't worry, I'm going to change it.
Okay, very good.
Well, pues gracias por acompañarnos. Bienvenidos a la sesión del día de hoy. Vamos a dar inicio a la conferencia de Brian Day. Les voy a comentar, Brian colabora con el Instituto Virtual para Exploración e Investigación del Sistema Solar de la NASA. Él es ingeniero en sistemas, realizó estudios de psicología, realizó maestría en astronomía y actualmente se encarga de los proyectos de vinculación con la sociedad, ciencia ciudadana, en este instituto SSERVI que les acabo de comentar. Es un gran amigo de Universum y we are ready. Brian, you can start.
Muchas gracias. Buenos días. Me llamo Brian y trabajo en NASA. Thank you very much for joining us today. We have a very exciting time. We are planning our return to the moon. And so what I thought I would do today is take a look at some of our plans for the moon and also talk about some of the places that we have visited on the moon in the past and some of the places where we would like to go in the future. So again, this is a very exciting time. We are coming up upon the 50th anniversary of the first human landing on the moon. So Apollo 11 landed on the moon on July 20th, 1969. And on that very famous day, astronaut Neil Armstrong took the first steps onto the surface of the moon.
Oh,
He and his fellow...
Brian,
yes, a question?
Yes. You're going to share your slides on your screen?
Yes, I am sharing. Are you not seeing them?
No.
Let's see if Ricky can help with that. Ricky, are you online?
I am here. I'm actually seeing the slides through Zoom.
Yeah.
Okay, but you are not seeing my slides, Pedro?
No, I only see your image.
Are you connected to Zoom?
Yes. Let me check. Participant. Oh yes, here it is. We are ready, Brian.
Okay, I want to make sure, because I want to make sure you are seeing the same slide that I am. So this should not be a picture of the astronaut on the ladder, but this should be a picture of an astronaut deploying equipment on the lunar surface with the lunar module seen in the background.
Oh
So,
yes. No, me pones. Brian, Aniversary. Let me check.
I will back up to my first slide.
Oh yes,
So,
we already have your. No,
okay?
no. Okay. Yes, we're ready.
Okay. So, again, we are planning our return to the moon. Our first landing of humans on the moon was on July 20th, 1969. And so we are planning many big events to celebrate the 50th anniversary of our first human moon landing. And here you can see examples of footsteps on the moon. And our astronauts, Neil Armstrong and Buzz Aldrin, returned samples from the moon, actual moon rocks. We'll talk about that in some detail. And they also set up equipment on the moon, like seismometers to measure moonquakes, and retroreflectors to be able to bounce laser beams from the Earth back off the surface of the moon and returning to the Earth, so we could very precisely measure the moon's distance. But now looking to the future, we have a new plan. And NASA has been directed to return humans to the moon in the next 5 years. So the Apollo program only went from 1969 to 1972. We have had robotic missions since then, but now we are planning to have humans return to the moon. And from there, we will go on to Mars. But our return to the moon will be different this time. It will not just be NASA alone. This will be an international effort, and it will be in partnership with private companies. And something very special along those lines is going to happen today. In about 4 hours from now, less than 4 hours from now, a company called Space.il in Israel is planning to have the first commercial moon landing. So this is supposed to happen today, this afternoon. So we are very excited about this. This will be the first commercial landing on the moon. And we expect many more companies to follow. This is important because these companies will be used by people like NASA and other agencies to take equipment to the moon. One of those companies, and there are many of them, but another one is Astrobotic. And here you see a design for the Peregrine Lander by the company Astrobotic. And Astrobotic is planning to send their lander to the moon in the next year or two. And on their first mission to the moon, they're planning to carry small robots from the Mexican Space Agency. So again, our return to the moon is going to be an international effort, and we are very much looking forward to working with Mexico on future lunar explorations. And it will be very exciting to see the Agencia Espacial Mexicana be the first of the Latin American countries to send actual robotic rovers to the surface of the moon. So what we're going to do today is we're going to use some tools that we have developed here at NASA and that you can use to explore the moon. We have a set of tools called the Solar System Treks that allow you to explore the moon, Mars, and many other worlds. So today we will use our lunar portal to get a close look at the moon, to look at where we have been and where we plan to go in the future. So this is our Moon Trek portal. And with this, you can zoom in, you can pan, you can move across the surface. Let's look at this crater. This is Tycho Crater. And one question you might ask is, how big is it? It is very easy to measure a distance. You just draw a line between any 2 points. And here we can see the Tycho Crater is almost 84 kilometers across. That's a big hole in the ground. We'll draw another line. This time we'll extend it on either side of the crater. And here we can generate an elevation profile. So with this, we can actually measure the heights of mountains and the depths of craters and valleys. This is a very exciting tool. But there's more to this. We can draw a bounding box around any piece of terrain that you like and use this to generate either STL or OBJ files for your 3D printer. So you can make 3D prints of any part of the surface of the moon that you like. You can also get into what we call 3D mode, and you can go flying interactively. So using the controls on your computer, you can manually fly down into the craters, fly over the mountains, and explore them in detail. So here we are inside Tycho Crater, looking at the mountain in the center of the crater. This is a very fun way to go explore the moon. We've added a new tool that is a lot of fun. This allows you to draw any path that you like across the surface of the moon. And once you have drawn that path, the program will come back with a QR code. And you read that QR code into your smartphone, and then you can put your smartphone in a pair of inexpensive Google Cardboard goggles, and you will fly whatever path you drew in virtual reality. So again, a very fun way to explore the surface of the moon. One of the real powerful aspects of this program, though, is that it allows you to view the surface of the moon seen through the eyes of many different instruments aboard many different spacecraft. We have over 1,000 different data products of the moon here, so many different ways to see the moon. So here, this is taken with a very good camera, but a regular camera, so that it sees the moon just the way your eye would. And we are looking here at a place called the Marius Hills. The Marius Hills is a group of volcanoes on the surface of the moon. But as we look here, it is not clear to me where the volcanoes are. They're not showing up very well. But because our program allows you to see the moon through many different eyes, we will now change to a different instrument. We'll look at this same area seen through the eyes of a laser altimeter. And now the volcanoes pop right out. You can go back and forth and you can see the difference there. We can also take a view through another instrument. We can look at a gravity map of the same area, and we can see how much different this looks. In this case, Red represents high amount of gravity. Blue represents a low amount of gravity. So we can have many different views of the same area. But we can also blend those views. So now I will blend the laser altimetry view and the gravity map. And with this, we can see the surface of the moon with the volcanoes on the surface, but we can also, because of the gravity map, now see beneath the surface and where the magma chamber, the lava chamber beneath the volcano complex is. This allows us to actually blend different views to see things that no one single view could show us. So this is very powerful. And this is something that, again, is available to you by just going to our website, Trek, that's trek.nasa.gov. So now what we'll do is we will use this program to explore some of the places that we have been to and some of the places that we plan to go. So here we are flying down to the Apollo 11 landing site in the Sea of Tranquility. This area was chosen because it is one of the smoothest, flattest places on the moon. But as we came down, the flight computer tried to land the astronauts in that big crater, about the size of a football field with big boulders. So the astronauts flew the spacecraft to the west and landed right here. You can see the landing stage of their spacecraft and their footprints were those dark lines. Here, Apollo 12 landed in Oceanus Procellarum, the Sea of Storms. And we can follow where the astronauts went from their landing sites, walked to visit a number of craters where they collected samples. And in one of the craters, they actually visited a previous robotic lander, brought parts of it back, returned to their spacecraft, and came home. Next, we went to an area of hills called the Fra Mauro area. This was Apollo 14. And these hills were formed by a giant impact about 3.9 billion years ago. So not nearly as smooth as the first two landings, a much rougher terrain. And there you can see the landing site and the path of the astronauts as they walked toward a crater called Cone Crater. There they recovered some samples that I will talk about at the end of this talk. Some very exciting discoveries were made there. Apollo 15 landed near the Apennine Mountains on the moon. Very tall mountains, about as tall as the Alps here on Earth. And as we look along the face of the Apennine Mountains, in the lower left now you will see some cracks coming into view where there had been volcanic eruptions. And coming out from that, you see what looks like a dry riverbed. That is Hadley Rill. No water ever flowed there. That was carved by flowing lava. Here we have a closer look at Hadley Rill, this canyon carved by flowing lava. This is on the slopes of a mountain that they climbed using a small car that they brought with them to the moon. A very spectacular area. Apollo 16 landed in the very rough highlands of the moon. This is the Descartes Highlands. And this is very, very old material, some of the oldest rocks that we have found on the moon. Much rougher terrain, much more difficult area to land. Here we are zooming down to their landing spot. You can see again the descent stage of their lunar module. And then we will pan across the terrain to see the craters that they journeyed across, heading up to the edge of what is called North Ray Crater. where they gathered many samples. The final Apollo mission, Apollo 17, landed in this valley, the Taurus Littrow Valley, deeper than the Grand Canyon here on Earth. So this was a very tricky landing, but by this point we had gotten good at it. There you can see our landing site. We will look up at the mountains surrounding them, and looking at the mountains we can even see the tracks of boulders that came rolling down the face of the mountain. We see a giant landslide that came off one of the mountains and extended 6 kilometers across the floor of the valley. And here we fly toward a dark crater amongst the landslide where they discovered ash from an ancient eruption on the moon. So these are the places that we visited in the Apollo missions. Now here's some of the places we are looking to go to in the future. This is a lunar swirl called Reiner Gamma. The moon does not have a global magnetic field, but the pattern of dark and light lines here indicate a local magnetic field here on the surface of the moon. What causes that field? We don't know, but we want to go there and find out. Here again are the Marius Hills. So this is a place that we would like to explore in detail. These volcanoes erupted over a very long period of time, many millions, even over 1 billion years. So because of that, sampling this could show us how the interior of the moon has changed over time. Here we fly down to some of the newest lava on the moon. This flat area in the foreground, this is called the P60 basaltic unit. So this represents lava that is perhaps only 1 billion years old. In the background, we have the Aristarchus Plateau. Again, a very spectacular area where a lot of volcanic activity happened. And again, you can see a very large channel where lava flowed across the surface of the moon. Lava on the moon tends to be very thin, very runny. But in a few places, the lava that was erupted is thick and pasty, like here at the Gruithuysen domes. So these are examples of much larger, steeper volcanoes than we typically find on the moon. Why was the lava here so different? Again, we don't know. That's one of the reasons why we want to go here, is to find out. This is the Aina caldera. This is a volcanic caldera that seems to be very, very young. We think most volcanic activity on the moon stopped over 1 billion years ago, but this may be less than 100 million years old, only a few million years perhaps. As we look at the surface of the moon, we see many holes in the moon, craters from impacts. But we also see a different kind of hole. We see holes that seem to be openings into caverns beneath the surface. These are skylights into lava tubes, subterranean channels where lava once flowed. This area is called Rima Bode, and the dark area you see there is volcanic ash. And strangely enough, that volcanic ash may be very rich in water. So we might be able to find water actually inside some of that ash. That could be a valuable resource for us as we go to live and work on the moon. This here is a large impact basin called Mare Orientale. We can see multiple rings of mountains that were raised by the impact. We can see areas where lava partially flooded the area. So we are looking to have this as one of our potential landing sites. On the far side of the moon, we don't see a lot of those dark seas, the plains of lava, like we see on the near side of the moon. But there is this one. This is Mare Moscoviense. And this is where the crust of the moon is very thin. We see deposits of volcanic ash here. We see some of those lunar swirls that indicate magnetic fields. So this is a very unique area on the far side of the moon. This is another area on the far side of the moon, a huge ancient impact structure, about 2,000 kilometers across. It shows up better in this laser altimetry view, where it's a deep blue in color. This is the South Pole Aitken Basin. And this is a big enough impact that it may have excavated all the way down into the mantle of the moon. Here we see the Schrödinger crater. Here we have volcanic ash, and we have areas of permanent shadow where the sun never shines. Again, this could be a very good place to look for water. And here we drive up to one of the volcanic craters inside Schrödinger. This area is called the Compton-Belkovich area. And this is again an area where the lava that was erupted was unusually thick and pasty. We don't know why. It is also an area that is very rich in the element thorium. We are especially interested in the poles of the moon. So here is the South Pole. And you can see at the South Pole, the shadows are very thick. We can pierce those shadows with laser altimetry, slope maps. We can see where the permanent shadows are, thermal maps, temperature. We can look for the presence of hydrogen, of frost, and even the distribution of ice. This is very important. Ice on the moon will be a critical resource. You need ice, of course, to drink, to stay alive, but we can break the ice apart into its components of hydrogen and oxygen. We can use the oxygen to breathe. We can use the hydrogen for fuel. We have discovered at the poles of the moon, there are billions of tons of water ice. That could be a very, very important resource for us. But one of the things I mentioned before was how our astronauts brought back a number of samples, quite a bit of rock from the moon. And this is important to us. As a geologist, you learn to be able to hear the stories that rocks have to tell. Rocks tell us stories of how they formed, of where they formed, when they formed, and the conditions under which they formed. Now, we would love to be able to find rocks here on Earth that tell us the stories of the earliest days of the Earth. We are all very dependent upon the Earth. The Earth is the one planet we live on. This is a very important world for us to understand. But on Earth, we cannot find rocks that are old enough to tell us the earliest stories. Here on Earth, we have wind, we have rain, we have plate tectonics. And so the old rocks on the Earth erode away. And we cannot find those stories that such rocks would tell. But we now realize that the Earth and Moon formed together in a giant impact about 4.6 billion years ago. And on the Moon, there is no wind, there is no rain, you do not have plate tectonics. And so on the Moon, we can find really, really, really old rocks that we cannot find here on Earth. And since the Earth and Moon formed together, those rocks can give us a clue about the formation of our Earth. But the story gets even better than that. This is very recent news because we are still going through the rocks that were brought back by the Apollo astronauts. Not all of those rocks have been analyzed yet. And there was this one rock recently that was being analyzed. And in that rock, they found a very interesting story. This rock did not fit with the rest of the moon rocks they had found. This rock looked very different. And when they started to study the rock, it told them an amazing story. It told them a story of how this rock did not form on the moon at all. It formed on the Earth between 4 and 4.1 billion years ago, about 12 miles down beneath the surface of the Earth. Then a large asteroid slammed into the surface of the Earth and blasted material from the Earth off the surface and into space. And some of that, including this rock, landed on the surface of the moon. Then about 3.9 billion years ago, another asteroid hit the moon, and a wave of molten rock went charging across the surface of the moon, and it buried our little Earth rock here. But then about 26 million years ago, yet another asteroid impact happened, and it dug this rock back up and left it on the surface, where the astronauts from Apollo 14 found the rock and brought it back to the Earth. So now the oldest Earth rock we have ever seen actually was brought back to us from the moon, where it had been kept and protected. So there are many wonderful stories and many wonderful adventures ahead of us as we go and explore the moon. Again, I will ask you to please feel free to use our software to conduct your own exploration of the moon. You can go to trek.nasa.gov, explore the moon and many other worlds. So with that, if there are any questions, I'll be happy to take them.
Abrir. Okay. Can you hear me now, Brian? Yes.
Yes, I hear you, Pedro.
Okay. Thanks a lot for your lecture. Thanks your lecture with some aplausos. Vamos a agradecer la conferencia con unos aplausos aquí en Universum y en las diferentes sedes. Before start the questions, I have to do a question for the people who is following in YouTube. En un momento vamos a las preguntas de las sedes remotas. Ya veo a Prepa 6, si nos encienden su luz en Prepa 6 y si activan su micrófono en CCH Oriente, en un momento vamos con ustedes. Pero antes, una pregunta para la gente que nos sigue por YouTube. Si quieren ganarse boletos dobles para venir a Universum, lo único que tienen que hacer es responder la siguiente pregunta. ¿En qué fecha fue la llegada del hombre a la Luna? Y contestar en nuestra página de Facebook Divulgación de la Ciencia, en el post de la transmisión. Brian, the first question from people at the YouTube mission is, you mentioned a private mission to the moon, and they want to know, are there any plans to visit the moon for normal people, for common people?
Ah, wonderful question. So are there plans for tourists to go
Yes.
to the moon? And yes, people are talking about that right now. So space tourism is a new industry that is starting out. And it'll begin with what we call suborbital flights, where you'll take off from the Earth, fly up high enough that you'll see the daytime turn dark. You'll see the surface of the Earth becoming round. You'll fly into space. You will become weightless, and then you'll fly back down. Short trip. And those will be starting in just the next couple of years. Next, then, you will have orbital trips where you will fly in orbit around the Earth. And eventually, there will be the opportunity to fly out and go around the moon. As a matter of fact, there are already companies like SpaceX that are talking about a tourist flight around the moon. Again, probably not too many years in the future, certainly within your lifetime. And then the big one will be to actually return to the surface of the moon, to actually have tourists go to the surface. That's probably a little further out. But space tourism is coming. You will start to see space tourist flights becoming popular within the next few years. I've got a question. How many of you out there, if you had the opportunity, how many of you out there would fly into space?
Here we are, a lot of hands up. Yeah, I think quiero verificar, ¿están conectadas las otras sedes? Ricky, did we lose the other venues? I don't see the other
No, I
venues.
still see them.
Prepa 6, sí.
Correcto. Yes. Vamos a preguntas con las sedes remotas. ¿Alguna pregunta en Prepa 6? Prepa 6, ¿alguna pregunta?
I'm seeing 3 locations on my screen.
Ok. ¿Alguna pregunta en Prepa 6?
Brian, can you hear me?
Yes, I can.
Okay, you just mentioned SpaceX could help in space tourism, but does these new technologies could also help on space research in the moon?
Very much so. Yes, very much. So we are depending upon many companies, including SpaceX, to help us in exploring the moon. As a matter of fact, the moon landing that is going to happen today, in just a few hours, just about a little over 3 hours from now, the moon landing used a SpaceX rocket to launch, and then the lander is from another company called Space IL. And so right now NASA has contracts with a number of companies to actually supply services for us to get instrumentation and scientific probes to the surface of the moon. So we will use commercial launch providers and commercial landers. And that is, again, that's exactly what the Mexican Space Agency is planning to do also. So this will make it much easier for all of the world's space agencies to explore the moon by having these commercial partners.
Gracias, Prepa 6. ¿Alguna otra pregunta o comentario? Puede ser en español.
No, gracias.
Correcto, les comento, puede ser en español y aquí intentamos traducirla.
Bueno, buenas tardes. Yo quiero preguntar cuántos simuladores se han creado y si aún se piensan actualizar estos recursos para, simular la superficie de la Luna o lo que vaya siendo sus composiciones del estrato de este satélite.
They want to know about the other simulators, the other web pages of other planets. Can you mention the different web pages?
Yes, okay, very good. Let me see if I can bring it up here real quickly. So I'm sharing my screen if you can see it, and we'll bring up my browser and I'll show you how we do this. So I'm going to go to trek.nasa.gov. And here we can see that we have...
Brian, I'm only seeing your PowerPoint at this time.
Oh, I need to share that. Okay, just a second. Let me go ahead and stop share and share browser here. Second. Okay. So here you should be able to see my browser screen.
Yes, we do.
So we have the moon. We can also go to Mars. So if I click here on Mars, Mars is fascinating because, again, we are planning many new missions there. We are planning to have humans on the surface of Mars sometime in the 2030s. We have the asteroid Vesta. So between the orbits of Mars and Jupiter, we have the asteroid belt. And Vesta is one of the largest of the asteroids. You can see that here. We have the dwarf planet Ceres, a small world, again, between the orbits of Mars and Jupiter. Ceres is spectacular. It has volcanoes that erupt water, volcanoes made of ice. Moving further out, we can go to Titan. This is the largest of Saturn's moons. And Titan is unique because it has a thick, dense atmosphere, an atmosphere that is even thicker than the Earth's. And finally, we have something called Icy Moon Tracks. And the icy moons actually explore 7 of Saturn's smaller icy moons. We can look at the moons Dione, Enceladus, Iapetus, Mimas, Phoebe, Rhea, and Tethys. So lots of worlds to explore, and we're coming up with more. So soon you will see Mercury. We will be adding Phobos, the largest moon of Mars. We will be adding more asteroids. So keep an eye on this site because there will be more worlds to come. Thank you for your question.
Okay, so we have to go to trick.nasa.gov and then it connects with the different simulators.
That's right. So with this, going to this one website, you can visit any of these worlds.
Okay, gracias Brian. ¿Alguna pregunta final en esta ronda, Prepa 6?
Buenas tardes, buenos días. Yo quiero saber cómo aplicamos las ciencias sociales al estudio de la Luna.
Oh, they want to know if social scientists work in the missions to the solar system exploration, how they contribute to the research of the solar system.
Absolutely. So here at NASA, people think of us having as just scientists and engineers, oh, and some astronauts. But we really have people of all different backgrounds working here, and that is essential. So we have teachers, we have artists, we have psychologists. If you think about it, when our astronauts go to Mars, and they are isolated for a 6-month journey to get to Mars, and then maybe a year on the surface of Mars, and then 6 months to get back. There's some big psychological issues there. We have lawyers, we have photographers, we have mechanics, we have people of every profession you can think of. And we need to have people of all backgrounds, because when we start talking about exploring the solar system, this is going to be a very human endeavor. And humans interact, we understand how humans interact through the social sciences. So understanding psychology and social sciences will be very important. In understanding the legal aspects, as we start moving out and using resources on all of these other worlds, how do we establish ownership? That is not going to be an easy question. And so just as we have international law today, we will end up needing space law. So all different fields of study will come together in our exploration of the moon and of the solar system.
Gracias. Gracias, Prepa 6. En un momento regresamos con ustedes para más preguntas. Les pido por el momento cerrar su micrófono. Voy a verificar si en CCH Oriente hay preguntas o comentarios. Si nos activan micrófono en CCH Oriente. Les recuerdo que las preguntas pueden ser en español y aquí intentamos traducirlas. Creo que no tenemos comunicación con CCH Oriente. I'm going to... adelante, CCH Oriente.
Hi, Brian. What do you expect to find on the moon? What will be your greatest expectation of discovery?
Well, I expect to be surprised. So when we go to the moon, we will find things that we never dreamt of looking before. But also one of the things that we are looking is, again, to find these resources of water ice. And that will be very important, because we can use the water ice on the moon perhaps as fuel to go explore deeper into the solar system. Fuel here on Earth is a very expensive thing, because we are down at the bottom of a very deep gravity well. The gravity of Earth is very strong, and Earth has a thick atmosphere. And so getting fuel off of the Earth is very, very expensive and very, very difficult. But on the moon, we can use that. Think of the moon as our solar system Pemex station. There, the fuel will be much easier to use to explore further destinations. At least that is our hope. What we need to do first is we need to discover how that water ice is distributed across the surface of the moon. How easy is it to get to? Would it be a major mining operation, or can we just scoop it off the surface in some of those dark, permanently shadowed areas? So those are some of the things we have to discover first. And then once we learn how to use that water ice to break it apart into its hydrogen and its oxygen, then we can use that as fuel to go explore the rest of the solar system.
Gracias, CCH Oriente. ¿Alguna otra pregunta o comentario?
Hi, Brian. My question is, why do you say doesn't set first robots to the moon?
Could you repeat that, please?
The question is about the robotic exploration on the moon.
Okay, so we have been doing robotic exploration of the moon for a while. We started that back in the 1960s. And so before we had any humans landing on the moon, we first had robots landing on the moon and orbiting the moon. And since we've had humans landing on the moon, we continue to have robots exploring the moon. Right now, we have the Lunar Reconnaissance Orbiter in orbit around the moon. I worked on a couple of missions, one called L-Cross, that crashed into the south pole of the moon and discovered water ice there. And another robotic mission called Laddie that actually went into orbit around the moon, then dropped down very low and flew through the moon's very thin atmosphere to help us understand what the moon's atmosphere is made of, what its structure is, and how that changes over time. So we are planning more robotic missions to the moon. And with that, we are partnering with many other agencies, the European Space Agency. There are plans being made in Japan and South Korea. And of course, the Agencia Espacial Mexicana has its plans for the moon now too, for robotic exploration. So when we go and make our return to the moon, it will be a combination of humans on the moon and robots. Humans and robots will work together exploring the surface of the moon in the future.
Gracias, CCH Oriente. ¿Alguna última pregunta o comentario en esta ronda? ¿Alguna
What do
última?
you think about, yes, Brian, what do you think about the first image to the black hole?
Oh, the first image of the black hole. That is fantastic. So when I was a student in college, I studied the supermassive black holes in other galaxies, in the centers of other galaxies. And I used telescopes at observatories. But I was never able to see the black hole itself. What I could see is the very bright area surrounding that black hole. That bright area caused by a whirlpool of gas spiraling down into the black hole. And as that gas would spin very quickly as it got close to the black hole, it would get very, very hot and glow. But we never had a telescope powerful enough to show us the actual black hole in the center of that glow. And I always wondered what it would look like. And we just found out this week. And we found out because telescopes around the world, radio telescopes around the world, here, there, across the world, were joined together through interferometry to form one giant telescope that was powerful enough to actually be able to show us that dark object at the center, the event horizon, where light, once it enters, cannot escape. And so for the first time, we were able to see this dark, dark silhouette of a black hole. Incredibly exciting. We've wondered about this for many years, and now, for the first time, we've actually been able to see it.
Brian, could we put a radio telescope in the moon and synchronize with the radio telescopes in the Earth to create a bigger telescope?
That is a wonderful question. So right now, people are talking about, well, we made this big telescope that was about the size of the Earth. But then people start wondering, well, gee, if we put radio telescopes out in space and combine the data from them, we could make a much larger telescope. And so people are talking about putting radio telescopes in orbit to make for an even bigger area. But at the same time, people are talking about putting radio telescopes on the moon, and especially on the far side of the moon. So one of our SSERVI scientists, Jack Burns at the University of Colorado at Boulder, has a very fascinating research program where he and his team are talking about putting radio telescopes on the far side of the moon, the side of the moon that never sees the Earth. And that's very important, because here on Earth, we make a lot of radio noise. We have TV stations and radio stations, and our cars make radio noise, and our blenders in our kitchens make radio noise. And so it can be very difficult to do radio astronomy of very, very distant, faint objects. But on the far side of the moon, that is the one place in the solar system that is always protected from the noise of the Earth. You have miles and miles and miles of thick rock of the moon between you and the Earth. And so the far side of the moon could be a perfect place to put radio telescopes that you could use to look further out and to look further back in time, perhaps even to see the time when the first stars in our universe formed and started to give off light.
Well,
So there are wonderful plans now to use the moon as a site for doing radio astronomy. We're very excited about that.
thanks a lot, Brian. Here we have another question.
Hello, I would like to know what's the most important cause for the active volcans in the moon, and if there anything data about the time of the active volcans.
Ah, okay. So we're talking about the volcanoes of the moon?
Yes.
Yes, okay. So that is a very interesting question for us. As we look at the moon, we see that it is a much smaller world than the Earth. It would take about 4 moons lined up side by side to stretch across from one side of the Earth to the other. The moon has 1/4 the diameter of the Earth. It's a smaller world. And because of that, we think its internal heat leaked out. And so the interior of the moon may have gotten colder and colder. And so volcanism on the moon, we had thought, probably came to an end about 1 billion years ago. So after about 1 billion years ago, no more volcanoes erupting on the moon. But then we look at areas like that Ina caldera, and they look disturbingly fresh. They don't look to be old at all. And what they may be telling us is that in spite of our theories, in spite of our best understanding of the moon, Perhaps volcanic activity has continued on much later, and perhaps even into very recent times on the moon. If that is the case, then our understanding of the interior of the moon is very incomplete. And our understanding of the evolution of the moon is very incomplete. So we want to go to some of these areas that look like very young volcanic areas to see if in fact they really are that young. And if they are, then we come to the understanding that our theories about the moon, our understanding of the moon, will need some very big revisions. That's exciting.
Thanks a lot, Brian. Here we have another question.
Hi, Brian. Enrique here. I'm questioning if NASA is planning to use the moon as a intermediate station for further exploration to Mars up to another planets at solar system.
Yes, so we are using the moon, if you will, our plan is to use the moon as a stepping stone to go to further destinations such as Mars. Deep space is a very different environment than low Earth orbit. So we have a space station now where astronauts live and have lived for long extended periods of time. But that low Earth orbit where the space station is inside the Earth's protective magnetic field. Whereas when you go to the moon or Mars or destinations beyond, you're outside that protective magnetic field and exposed to galactic cosmic rays and solar storms. And that presents a whole new set of challenges to us. We have to learn how to live off the Earth for extended periods of time in areas that are far harsher environments than just in near Earth orbit. And probably the best place to learn how to do that is the moon, because it is so close to us. It's only like 3-day journey away, as opposed to Mars, which is a 6-month journey. So we will develop the technologies and learn the strategies that we need to live for extended periods in deep space by going to the moon first. And then we will take that knowledge and use that to go to further destinations such as Mars.
Okay, thank you, Brian. Elitesi, who's following from at the internet, wants to know, can you mention the different countries that are exploring the moon?
So, right now, China has a rover on the far side of the moon. That is the first successful landing on the far side of the moon, so that is very exciting. Japan, India, the European Space Agency have all sent probes to the moon. Russia, of course, was the first to actually provide us with robotic views of the far side of the moon. Russia did some very early exploration of the moon, and they continued on with robotic landers that actually returned lunar samples. So Russia is a major player, the European Space Agency. South Korea is currently planning a lunar orbiter, and they eventually are planning to do a lunar lander too. And of course, then in Mexico, the Agencia Espacial Mexicana. So, and more countries are making plans too. And as we have these commercial partners, they can provide launch vehicles, can provide rockets, and can provide landers. It becomes less expensive to actually send experiments to the surface of the moon. So what we are looking forward to is to having many countries sending experiments and becoming participants in the exploration of the moon.
Okay. From the internet, another question is the new missions, are they using new propulsion technologies?
So new propulsion technologies are definitely being developed. And so when we looked at Vesta and Ceres on our solar system treks, all of that data came from the Dawn mission, DAWN, and that used ion propulsion. And some of our other spacecraft now that are out visiting other asteroids also have used ion propulsion. That is a way of achieving much higher velocities than we have done with chemical rockets. So yes, new propulsion systems are being developed and have a great potential to make it easier and quicker for us to explore deeper into the solar system.
Thanks, Brian. Voy con las sedes remotas. Una última ronda de preguntas. Prepa 6, si nos activa su micrófono para saber si hay alguna pregunta o comentario final.
Could you hear me? I have another question.
Yes.
Yeah, okay, thank you. Well, one of the main objectives of humanity is travel around the planets, we know that. But sometimes this could sound like, as we were talking about science fiction or something like that. But some enterprises like SpaceX are making plans to visit the nearest planet, that is Mars. And the CEO of these companies said that probably in 2022, we're going to be able to go there. But do you really think that we are able to go there, or do we have the technology to arrive there?
Well, we know that we have the technology to send robots to Mars because we've done that very successfully. The question is having humans on Mars. And that involves some technologies that we still have to develop. It's nothing that we should not be able to do, but it is going to require us to answer some questions. For instance, we know that the gravity on Mars is about 1/3 that of the gravity here on Earth. And we know from our experience in being in Earth orbit that it is not healthy for humans to be in very low gravity for a long time. Essentially, when you are in Earth orbit in the space station, you are weightless. And we know that that is definitely unhealthy for you. Your bones become less dense. Your muscles weaken. Your immune system weakens. Your eyes are affected in a bad way. So we know that being weightless is not good for you. But how much gravity do we need to be healthy? Do we need a full 100% of the Earth's gravity? Is half gravity good enough? 1/3 gravity good enough? We don't know the answer to that yet. The gravity on the moon is 1/6 that of the gravity on Earth. So by going to the moon and living and working on the moon, we will gain a better understanding of human responses to a lesser amount of gravity. That's an important question to understand before we go on to Mars. There are also issues with radiation. There's a lot of unknown things that we want to resolve before we put humans on the surface of Mars. Unfortunately, going to the moon will help us answer those questions.
Gracias, Prepa 6. ¿Alguna última pregunta o comentario?
Hello, Brian. Can you hear me?
Yes.
Okay. How is nanotechnology improving space research?
Oh, how is nanotechnology?
Yes, nanotechnology. How is improving? Yes.
So nanotechnology is something that we are investigating in many, many different ways. In terms of materials that we would use. I'm trying to think of specific examples, and I should be able to come up with better than I am, but I know in terms of a lot of materials research, especially in terms of spacesuit design, designing a spacesuit for use on the surface of Mars or the surface of the moon is actually very different than the kind of spacesuit you would want to use doing a spacewalk. Very different environments. Looking at things such as minimizing the adherence of dust. Dust can be a very tricky problem, especially on the moon. It is very abrasive and can wear through joints and surfaces, and it's something that you definitely don't want to breathe. So something that nanotechnology might be able to help us with is helping to make surfaces that dust does not adhere to anywhere nearly as it has in our older spacesuits. I'm sure there are many, many other examples, but that's just a start.
Oh, gracias, Brian. Thank you, Brian. Gracias, Prepa 6. Les pedimos por favor cerrar su micrófono. Voy a pasar a CCH Oriente para verificar si hay alguna última pregunta o comentario. Si nos activan micrófono en CCH Oriente, adelante.
Los jóvenes ya no tienen preguntas, pero a mí me gustaría saber si tienen planeado algún festejo por ya haber cumplido pues casi 30 años de haber lanzado el Apolo, 50 años, perdón, de haber lanzado el Apolo.
Yes, Brian, can you mention about the celebration of the anniversary? The activities?
Absolutely. So we are very excited about the upcoming 50th anniversary. There will be a number of events broadcast on NASA TV, which you can see by going to nasa.gov. One of the things that will happen beforehand is we will actually be rebroadcasting the actual landing on the moon. So
the original video?
The original video. So I know, so I am old enough to remember it. You folks are not. But it was very, very exciting to watch as the first humans landed on the surface of the moon. So that will be one thing that is happening. There's some new movies that have come out. So there's a new documentary movie called Apollo 11 that I highly recommend. Very, very good. There are going to be, here at SSERVI, we are going to plan to have a webcast where we will have scientists who worked on the Apollo missions and some who are working on future missions come together and talk about the exploration of the moon. And Pedro, I will supply that information to you so that you can share that with your students so that you can hear, again, a more detailed discussion of where we have been and where we are planning to go.
Thanks a lot, Brian. That's the final question. I know you are very busy today, so we want to thank your lecture with un aplauso de las diferentes sedes. Voy a agradecer a las sedes que nos siguieron por internet, el ITESI, el Colegio Real Motolinía y los centros pilares por videoconferencia, Prepa 6 y CCH Oriente. Thanks a lot, Brian. Great lecture.
Thank you so much.
I will send you the paper about your participation.
Okay. Thank you, Pedro. It's good seeing you again.
Thanks, Brian. Gracias a las sedes que nos acompañaron. Terminamos la transmisión. We finished the emission.
Very good.